Hello and welcome. My name is Shannon Kemp, and I'm the Chief Digital Officer for Dataversity. We would like to thank you for joining today's Dataversity webinar, What's in Your Data Warehouse, sponsored today by Anomalo. It is the latest installment in a monthly webinar series called Data Ed Online with Dr. Peter Aiken. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we'll be collecting them via the Q&A section, or if you'd like to tweet, we encourage you to share your questions via Twitter using hashtag DataEd. And if you'd like to chat with us or with each other, we certainly encourage you to do so. And to open and access either the Q&A or the chat panels, you may find those icons in the bottom middle of your screen for those features. And just to note, the Zoom chat default sends to just the panelists, but you may absolutely change that to network with everyone. To answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days containing links to the slides. And yes, we are recording and will likewise send a link of the recording of the session as well as any additional information requested throughout the webinar. Now, let me turn it over to Zach for a brief word from our sponsor, Anomalo. Zach, hello and welcome.
Hey, Shannon, really appreciate it. So let me share my screen and let me hop into what we'll be going over today. So first of all, hey, everyone, my name is Zach. I'm a solution engineer here with Anomalo. My background was as a data engineer or data analyst at Capital One, data engineer in hospitality, as well as ad tech. My previous position was at Tableau. I was helping clients with visual analytics. So suffice to say, across my entire career, every single job I've had, every single data set I've helped clients with, my entire experience has been plagued by data quality issues. And here comes Anomalo. That's why I joined. So what Anomalo is a modern data quality platform that automatically catches anomalies in your data and finds the root cause. So we're going to be going into a quick product demo of what Anomalo can help with in the data quality space. First, I want to go over a quick background. So here in the modern data stack, there are going to be anomalies that can occur in quite a few different places. So first, of course, they can occur way upstream when we're ingesting data, or they can even occur at the source. But beyond that, even after we take that data, we can create anomalies through our ETL process, or maybe through orchestration, maybe our pipeline breaks, or our business logic could be implemented incorrectly or don't handle a certain type of exception. Beyond that, we can even have data quality issues at our enterprise data warehouse. And this is a big problem because this is the source of truth for all analysts and end users downstream. Who can also experience data quality issues. Maybe calculations can be miscreated within dashboards, or ML models aren't trained properly. So where should we monitor data quality? This could happen right at the enterprise data warehouse level. And the reason being is we'll be able to catch everything at the enterprise warehouse level, including what comes upstream, both at the transformation level and the ingestion. So this will protect end users. And we know that any anomalies that might occur here could be end user generated. So if we're monitoring data, there's going to be 3 different things we'll have to do. First of all, of course, we're going to have to detect that there are issues occurring. We need to do that proactively. But not only that, people need to know. And the way we do that is by sending alerts through tools like Slack or Microsoft Teams. And then finally, after people know that there are issues, the next step is, of course, to make sure that they're resolved. And that can often take a lot of time. So we need a way to root cause those issues as fast as possible. And so ideally, what a data quality monitoring platform would be able to do is to automatically take care of all 3. So there's 3 different types of checks we could do. And actually, I think I'll jump into the demo and go over them there. So here I am in Anomalo. And what we'll be doing is we're going to monitor a certain data quality set. And this is my fact listing table, and it contains ticket sales data for shows and concerts in the United States. So the first thing we'll be seeing is 6 different categories of checks right here. But before hopping into those, I want to take a look at this visualization. So what Anomalo is giving me here is a profile of my data. So all these columns are within my table, and within these columns, my venue state, for example, I can see a distribution on the records. So I see that it's quite common for venues to be located in New York and California. So I know that there could be potentially a lot of ticket sales here. So going into the actual checks, the very first line of defense is data freshness and data volume. So data freshness, just asking, is my data arriving on time? Is yesterday's data here in my table? And data volume is going to be saying, okay, I know that at least some data has arrived, but have all those records arrived? Is my data complete? So what we'd want to see here, and what Anomaly is doing, is it's calculating the total number of records that are loaded each day, plotting them over time, and then generating a time series model. And what that model is doing is trying to predict that range in which on any given day, the number of records should fall. So it looks like yesterday we were right in between that range, but a few months ago, we would have received an alert because this was well below that expected range. Now, of course, these models are going to be taking into factor components of seasonality. So for example, if I expect no records to come in on weekends, or maybe very few records, then this time series model will adjust. And the next time it happens on a weekend, it'll say, hey, this is actually normal. So these first two, you may have heard the term data observability thrown around a lot in the industry. These fall under that. It's a very shallow level way of monitoring, but we want to go a lot deeper into the actual content of the data itself. And the two ways we could do that is using unsupervised machine learning or custom checks. So with unsupervised machine learning, the objective here is to automatically catch issues without any sort of configuration. I don't have to write rules here. So we could either look for significant increases in missing data, such as nulls, zeros, or drops in particular segments. So for example, the total number of records in the table may have not dropped, but this pop segment could have dropped 30%, and I want to catch that. Or we want to detect if data changes in any significant way, if there's specific drift. And now we'll go over an example of this in a bit. And then finally, we have key metrics and validation rules. Key metrics are going to be KPIs that I'd want to monitor over time. So let's say I care about the average number of tickets I'm selling. I'm a data scientist or data engineer, and I want to self-service in a very simple way. So what I would do is click on this icon, and without any type of coding experience, I'm just going to look for my average. And all I have to do from here is just select my column, my number of tickets column. So I do have advanced options, but I'm just going to run this without any other configuration. So no coding is actually needed. And let's hop into this. This should already have finished pretty quickly. Okay, cool. So I actually just got an alert in Slack. So Anomaly caught an anomaly. It also alerted me. So I'm getting this proactively. And I could take a look at this in Anomaly. So here I could see that the average number of tickets is generally around 10 and then shot up to over 13. So where key metrics are going to be things we'd measure over time, validation rules, we actually care about every single value within a column. We're getting very granular here. So we might care that every value in our list time column is never null, or every value in my list ID column are going to be unique. So what this check is doing is saying when I multiply column 1 by column 2, it should always equal column 3. And Anomaly is saying there are 233 records that fail this check. They don't follow this relationship. But what's more than that is it gives me insight into why this is occurring, where in the data it's happening. And what this is saying right here is 100% of the bad records in my data set, and that would be these 233 records that fail this check. Anomaly is saying, do you know what all of those 233 records have in common? They happen to have a venue state in New York. But at the same time, only 26% of the good records in my data set have a venue state in New York. So this is extremely significant evidence that a much higher percentage of my data occurs in this venue state of the bad data, and I know to address my issue there to help me find that root cause. Now, the last thing I'll mention is these are really easy to set up. We, without any coding, we just clicked a few buttons, Anomaly calculated the metric. I plotted it over time, generated a time series model, alerted us when there was an anomaly, and I even got a root cause analysis, but that's still not enough because I don't want to have to write hundreds of thousands of rules for my enterprise data warehouse. So the last thing I'll mention is this unsupervised modeling check, which is saying I found a really severe anomaly. All of a sudden, my number of tickets column, the value 40 shot up. Now, we saw earlier the average went from around 10 to over 13, so this might be correlated. And here's giving me a tornado plot where it's saying, what if I took the most commonly occurring values for yesterday's data and compared yesterday's data to the data from the day before? Now, for most of these values, they don't change much day to day, But for the value 40, it went from 0% to over 10%. So the last visualization is just giving me the same root cause that we saw before. And why this is so important is if I hadn't known to create a custom check for this specific type of anomaly, Anomalous would have found it for me anyway. I'll pass it off to you, Shannon, but thanks everyone for your time. Happy to answer questions later.
I thank you so much for this great presentation and for kicking us off here. If you have questions for Zach or about Anomalous, feel free to submit them in the Q&A portion, as he'll be joining us at the end of the webinar for the Q&A with Peter. And now let me introduce to you our speaker for the webinar series, Dr. Peter Aiken. Peter is an acknowledged data management authority and associate professor at Virginia Commonwealth University, president of DAMA International, and associate director of the MIT's International Society of Chief Data Officers. For more than 35 years, Peter has learned from working with hundreds of data management practices in 30 countries, including some of the world's most important. Among his 12 books are many firsts, starting before Google, before data was big, and before data science. Peter has founded several organizations that have helped more than 200 organizations leverage data-specific savings that have been measured at more than 1.5 billion. His latest is Anything Awesome. And with that, let me turn everything over to Peter to get his presentation started. Hello and welcome.
And hello and welcome to everybody. Shannon, thank you so much. And Zach, what a great demo on that. I look forward to welcoming you back in about 50 minutes so we can chat some more on this, because Zach very well exemplified the problem of bad inputs cannot help to lead to anything other than bad outputs, even if you put something awesome in the middle of it. So first little bit on this, let's talk about the title here. And it's always important as analysts to understand the questions that we're trying to ask. So when somebody asks what is in your data warehouse, that may be the question they're asking, but I'm guessing it's more along the lines of, what are you guys doing with respect to data warehousing? And that can be a very different question than, what's specifically in the content there. And if we're going to do it that way, we probably need to change the order of the words. What does your data warehousing operations consist of? Of course, we're ending in a preposition, so that's not right. Let's move that around. So of what do your data warehousing operations consist? Probably not the way you'd ask it if you were thinking about it, but let's take a premise from that and look at it from 4 different perspectives. First of all, defining what we mean by broadly data warehousing. Look to the DIMBOK for some specific guidance around that, and look at it in the context of what everybody out there is experiencing, at least a degree of, which is some sort of legacy to digital conversion, typically involving, of course, cloud facilities. We'll break that into 2 parts. The first one focuses on the subset of data warehousing that are largely focused on addressing integration problems. And then the second chunk will be focused on data warehousing capabilities that are really involved in preparation of data in anticipation of being presented out there. We'll finish up with some best practices. And after a quick takeaway, we'll come back for some Q&A. So I found that there's 2 types of individuals that are usually interested in the thing here. Sorry, I've got to get rid of the interested in the program. And the first one are folks that are just approaching the subject, even though many people have been in data warehousing for decades at this point, but that you still have are faced with a need to integrate separate, disparate data components, and that somebody somewhere is clamoring for a more holistic view of the business operations. Management may have just pulled a magazine out of the back of the airline pocket and said, oh, warehouse is great, let's build one. I mean, these sound old, but it's still happening here. The other type I find, the people that are interested in this material, is people that have overly complex or messy practices, and they're looking to make some improvements on them. So let's jump right in. Start off with data warehousing as a result of an input process output diagram component here, where the output from this process that I've just shown here, input process outputs, is warehoused data. So what we've done is kind of difficult to show that there's value in taking data that we have in parts of the organization and duplicating it in another part of the organization. By itself, it would be very difficult to show some business value. But when you start to show that this warehouse data can be used by a number of different applications for different subsections of data optimized for certain types of presentations and things. That makes a very different story. You still have the process of accounting for this, making sure that the investment, if I told you this cost $1, we'd be all very excited. If I told you it cost $1 billion, you'd think twice or perhaps 3 times before you jumped in with both feet. In addition to that, what most people look at here is a thing of value in your organizations. Your ETL infrastructure that you have in and of itself is a major source of data structure and transformation knowledge that will be incorporated into your digitization process. If it's not, you're missing the boat in a very major way. Our Dimbach wheel, if you're seeing this for the first time, is the idea, the expression of what it is to do data management. You can see I've highlighted that data warehousing, business intelligence management is a wheel, is a wedge in our pie on this. We have a subsection here, again, our own version of the inputs, processes, that's called activities, in this case, outputs that are there, and some additional material. These are very good references. I'm certainly not going to walk you through these. A definition, though, of warehousing is in order. One of the things defining it broadly is a technology solution that supports business capabilities such as query, analysis, reporting, development, and also development of these capabilities. Some people will say it's analysis of information that hasn't been previously integrated, and some people say it's a new set of organizational capabilities that we need to be able to maintain. If we shift now from data warehousing to business intelligence, even though these are often linked, the conversation around business intelligence has existed since before I was born, back in the 1958s, in that sense. And it's always been trained on focusing decision-making processes and improving it, which means we can have certain technologies, et cetera, involved in the process, and that the obvious place most of these start is trying to look at historical patterns and see if historical patterns are going to enable you to predict future performance or improve future performance. Some people drop it down to the definition of just saying using math in business. Again, no standard definition there, but you can see none of them involve necessarily technology in that sense. Then we have the term analytics, and I have a real challenge with that because I have trouble defining it. So when you look at these definitions here, they say, well, it's got to do with models, and that's neat. The way I would approach this is to say, most organizations come and say, what data warehouse should we build, or what capability should we address with data warehousing? The question really should be, how can warehouse-based integration address business challenges that we have? And unfortunately, I'm going to start with a negative example, which is something that we have to fight uphill with in all cases in this case. You may not remember where this particular bit was from. Yes, Indiana Jones and the Raiders of the Lost Ark. And if you remember the story, it was something at the end of the movie getting stuck somewhere in a warehouse, never to be seen again. Of course, that never happens. Well, here's a live example for you from a healthcare company that had 1.8 million members, and of those, 1.4 in the data warehouse of the 1.8 million members were marked also as providers, which, if you think about it from a business perspective, meant almost everybody could have their own personal physician. On the other hand, there were 800,000 that were in this data warehouse that had no key. Having a key meant that they were inaccessible under any circumstances. 29% did not have a provider social security number. So again, there's another 30% of the data that is inaccessible. Actually, only 2% of them had the required 9 digits on that particular number, provider number. Sometimes it was a synonym for the other. Again, you can see it's confusing. And of course, when the boss found out it had one user and cost 30 million a year to run, this was a problem because the boss clearly understood, I can take a room full of MBAs and lock them and slide pizza under the door and accomplish this analysis in a much faster fashion. Now, the reason we have to do this is because our systems grew in our standard legacy fashion. They grew up as individual siloed applications, and most of the time data was formed around them. And the way to look at this of problematic is to say that as things connect to other things, they become more complicated and more brittle and less flexible. And of course, as business needs change, the need to change the technology around it oftentimes accompanies that. So ideally, what we'd love to do is to integrate this by saying, hey, let's put some new technology in the center of this and start putting data in there, and that'll give us some organizational data. And clearly, we've got the ability to distinguish it because it's in the center. Then we can re-architect around these other aspects and come up with a wonderful spoke and hub model, assuming that's what we've decided is useful for the organization here. We're not talking to architecture, just trying to get the concept of the data at the center. That said, that's a very traditional view of warehousing. There are some things that should be looked at, which we could take an entire webinar to go through, things such as linked data, which can do these things for literally a tenth of the cost. And that is something worth looking into because there's such a large community and a vibrant set of organizations. It's not a panacea, but there are some very good answers in there that are just tremendous starting places. In addition to that, there's the concept of virtualization. Do I really need a physical warehouse, or can I virtualize it in some fashion? The answer, of course, is yes, with the ultimate result being cloud. I'm showing Amazon in this particular case. Similar kinds of things are true about their offerings. In fact, Gartner is the one that's recommended that cloud selection is really a question of accessing the data that's available easily under that cloud, as opposed to the specific cloud features. Well, I've said cloud 3 times. I suppose we should define it. The real key is, first of all, location independent, and at the same time, shift of risk so that you're running the right operations in the right regions, all that. And that virtualization is a clear component of this, with the ability to spin up and spin down in capacity with details that are abstracted from everybody's particular daily pieces. The scalability is another often touted approach, where people say that as your demand increases, if you're doing it from a physical perspective, you have only the option of adding things in a step function, whereas the obviously can be done the opposite here by tracking very closely with supply and demand. Similarly, however, it can be expensive because the concepts around this are linear increases in almost every increase, whereas you get none of the economies of scale that you used to. Of course, every organization has got a virtual road to the cloud, which is a wonderful thing, but notice they're not talking specifically about warehousing. They're just talking about different cloud capabilities and options. And again, we could go into another webinar and get things on there, but I'd like to bring home, whether we're talking about clouds or warehouses, there are 3 things that we need to pay attention to. First of all, I hope you're all in agreement with me that the data that is inside the cloud should be of cleaner than data that is outside of the cloud. If the opposite was true, if it was dirtier, I think we'd have a different conversation going on around this. The data in the cloud should also be smaller by definition on that. And the reason it should be smaller is because it should be architecturally more shareable. You can architect shared structures that will help a lot at the organizational integration level. These 3 are particularly important because most of what happens in the warehousing environment that's problematic follows what are relatively poorly done practices, consisting of literally forklifting the data into the cloud. Notice the cloud also expanded to make sure it could accomplish ingest all the data. The problems, of course, with forklifting is that there is no basis for the decisions that are being made, if there are any decisions being made. It completely ignores any guidance from an architectural or an engineering perspective. There is no concept on the team that these ideas are missing in the first place. And let's get frank, 80% of all organizational data is redundant, obsolete, or trivial. So the way it should be done is that the forklifting here brings this into an organizational context where we shrink it, we improve it, we make it clearer, we make it less in volume, we make it cleaner by definition on there, and more shareable in order to do this. And this is true whether you're warehousing or clouding. And of course, typically you're probably doing both at the same time. Interestingly, this brings on an opportunity for something that we call data branding, where now you can say this data that is in this warehouse or cloud-based warehouse, if you want to be precise about it in those circumstances, is of cleaner. There is less of it that you have to get to know and wade through in order to find what you're looking for. And it's an easier data set to look at. And of course, the real problem is if you just forklift your data in the clouds, you're kind of cleaning it like these individuals are working with things. There's sort of stuff in there, but it makes it more difficult when you're using that component there. So let's dive into this first integration piece. There are 2 purposes for a data warehouse in general, and they're not precisely articulated, but you'll see they're subtly articulated in here. First of all, the purpose is integration, that you have disparate data sources. Even though most data is never analyzed, there's a lot of opportunity around this. I was working with an organization that in just 1 week had identified 100 more points of integration on a central point that they had than they really anticipated having on this. And it's going to have the same kinds of inputs and outputs, data characteristics. And quite frankly, it probably to some degree is working at the moment. So there's some downstream knowledge that is incorporated upstream. We're able to take feedback from what's happening and improve the overall process. The other type of warehouse purpose is literal preparation, the last mile of the data before it becomes part of the decision-making activities. These are usually closed-ended activities, which gives one last opportunity to check programmatically for quality measures of the type that Zach was describing to you just moments ago. So Zach, I'm assuming when you come back online, we'll talk about your ability to integrate into this environment. But here's the key for everybody: choose one up front here and make a decision and try to stick with it, because they will have an influence. And that's what we'll spend some time talking about, is how this influence needs to be accounted for. We'll first do the integration, and then we'll do the preparation concept around this. The integration we're already in. If we ask the question, how much is it going to take to connect everything to everything else here? The answer is a frightening 15 n times n minus 1 divided by 2, our formula for this. And if I look at this in a particular example, the client that I was working for at the time, the Royal Bank of Scotland, told me Royal Bank of Canada. I don't know how that happened. I was thinking about Scotland for some other reason. They had 200 major applications at the time, resulting in about 5,000 batch interfaces back and forth between them. So those are good numbers to take a look at. In fact, if we start to look at the numbers, here's the problem with connecting everything into everything else. Obviously, the worst case in all cases is what's being plotted on the yellow line, but let's look at the 200 and the 5,000. That's not a bad place to be necessarily when you look at where you potentially could be. But my goodness, 5,000 actual interfaces is very, very problematic. Now, the basis for data warehousing is incorporated and really best articulated in Inman, Inhofe, and Soma's very fundamental book, Corporate Information Factory. There's lots of used copies of it floating around. It might even be in Google Books by this point to take a look at it. And the main thing to think about it is that they look at the process of producing data in data products as a production process, a mechanized production process. And so in that sense, it has a very good approach to this engineering. Here, for example, is a same exact picture as on the first part, but this is applied to a specific challenge, in this case, hospital performance management. So you can see all of the various claims information comes in through these top pieces, goes into this one platform where there is different types of access to it: workflow, access, patient and physician portal, and the dashboards that they have on this. And to be very specific about this, it is called an Inman warehouse, and his definition is a subject-oriented, integrated, time-variant, non-volatile collection of summary and detailed historical data used to support the strategic decision-making processes of the organization. It's a very precise definition. What he's talking about is taking various sources of data, bringing them into precisely defined staging areas for a first set of transformations, then a move into a warehoused, a governed environment. In this case, again, the branding opportunity is still potential right there. And then moved out of that warehouse to a series of data marts, where then they are accessed by the users, but nobody directly accesses the data in the data warehouse because it's operating at what we call third normal form, which is not the easiest form to understand or navigate. And so unless you have very, very user accessible opportunities here, you will have very little purchase of people trying to actually buy into these. And there's some typical pros and cons. There's perfect, as close to you can get as little data, least data redundancy. We can do things like enforce referential integrity and attribute specific indices that give us flexible querying and things like that. Joins can be expensive. Again, you don't really want to work in it. You want to store things in the data warehouse and then pull pieces out of it to work on it out there, which makes it a big operation and one that we have to specifically address from an engineering-oriented versus an architecture-oriented perspective. There's no one correct or incorrect, but for what we've been talking about, you can see it's a more complex project, particularly since the second part of this I'll give you will be an easier definition. So the engineers help develop these technical designs, which are very complex, but an architect is required to integrate engineering perspectives to bring them into it. And so it's important to make sure that you have the ability, if you're moving on this type of a journey, to emphasize engineering talent, particularly data engineering talent, that will be helpful to do this. If you do so, or if you're considering doing, I'm sorry, went too far, let me go back. Okay, particularly if you're doing something such as Target was reported doing here in this particular example. They are showing a slide from a Target data scientist who was unfortunately so perhaps unaware that perhaps the activities that they were doing, such as predicting whether guests were pregnant or not, might be not tasteful, and actually presented this at a conference of people that were doing it. And a newspaper reporter from the New York Times saw this, wrote an example, which Target later disavowed and said it never happened. It was a big brouhaha. But the point is, this is a very carefully engineered system. Anything that you touched at Target would link back in to whatever you're doing. And the challenge with this from an integration warehouse perspective is that you're going to obviously have these diffuse applications on here all the time, but that somebody, for example, who might be called a chief analytics officer would only be concerned with the right-hand side of this diagram, everything to the left of the yellow, excuse me, to the right of the yellow line that you're looking at. And unfortunately, that doesn't leave the best opportunity, which is to take that learning and feedback arrow that's there and point it back into the black box of the data management practices, where you have even better leverage, even more opportunity to impact things that are happening in your environment. Let me give you two very quick examples, and then we'll move on to the next one. The first one is an organization that was very, very good at feeding people. Again, the ability to crank out thousands of sandwiches quickly in an emergency was par excellence. And they were just curious, what else could their data do? And so after an interesting work with them, it was discovered that in a certain city where they had good definitions of food and food deserts and things of this type, they were able to take a bus line that used to run down, let's just say Main Street, or what's a Broad Street in Richmond, Virginia. This is our dash line that we have out there. That if we deviated slightly and just made a small change in the routing, it would impact thousands of people in terms of their ability to obtain good quality of food. And the organization here, as a philanthropic organization, felt this was a great way to enhance their own use of the data. No way they would have been able to come up with this if they had tried to focus on an end product. They simply had to go with an exploration mission around all that. So let's dive down into preparation here as well. Business intelligence is a very, very interesting field. Unfortunately, it's not very well defined or not very objectively defined. And so while you get these nice looking pictures, it's kind of hard to really operationalize it. But the basics are that users can drill down anywhere, and that there's a sort of conceptual cube that they use to figure out what they're doing, giving you the ability to summarize or drill down very, very specifically. And of course, there are emphasis around this on this n-dimensional cube, in this case showing 3: product, time, and geography, but you could just as easily add in other dimensions, not necessarily from an engineering perspective, and most importantly, not without rebuilding the data cube. That should make sense. If we add another dimension, we'll need to rebuild the cube, or if we change significantly a dimension, we'll need to rebuild the cube. Hence why you saw that previous separation of them in here. We'll see in this case, it's much more integrated and straight to the answer type of thing. And it permits, this type of an arrangement permits different uses where people can dive in and look at cancer patient revenue, or the revenue for disease in the Northeast region, or which are the total costs and revenue for the top 10 perspectives, giving you different facilities, different perspectives. Again, more specifically, you might be able to take a data set that's very large and cut it down to say, I want everybody who has income less than 100,000 or is younger than 30 years old, and then lives in the city of New York. So now we've gone from 30,000 customers to 6,000 customers. who purchased something X, whatever it is we're looking for in the last 7 days, and that takes us from 6,000 customers to 800 customers. And then we say who live in New York, purchased in the last 7 days, and who supplied those pieces. So you can see reverse engineering this particular approach and saying what's going on here. Think of us doing sort of a law and order context on this. Could not do that without the data structures pre-existing. Very difficult to do in real time without good data structuring around this. Another example, just a banking analysis, we can have different cube dimensions, again, social status, geographic location. Some organizations are now trying to predict whether you're a good candidate for credit or not based on your social history. Sounds like an interesting proposition. We'll probably have to learn more about it before we can figure out. So, your approach in the banking environment is going to be balance the loan with the risk of default. You can loan more money to people who are likely to pay you back, but you will charge less interest rate in order to do that. And so that's going to give you a couple of solutions, where to go, what to do. This can be the kind of tool that can help you to answer those questions. So in this context, we call this a Kimball warehouse, a copy. And notice his definition is much simpler than Mr. Inman's definition. By the way, that neither has ever agreed on anything except, I'll show you at the very end, a new design, a hybrid design to get you started in these. But it's important that you understand the distinctions because this is what's out there. So it's a copy of transaction data that's specifically structured for query and analysis. Same operational systems coming in from the data sources. They go into a staging area, but they're directly put into, instead of this centralized data warehouse, they're directly put into use. And this allows you then to have different types of ability to report. And the beauty of this is something called a star schema. It means that the fact, whatever you're trying to store as the unit of, I want to add, subtract, go up and down the abstract here, is the central table in that, and that if you incorporate the right types of dimensions, each of those dimensions represents a possible data analysis. And so it gives you a lot of specific cases that are very easy, very short to results in terms of moving on through. Simple to design, not so good for turning into something else later on in order to do this. Hence, again, remember the guidance earlier on to pick one and decide which way to go. Although, again, I will show you a trick on that. The key is, of course, if you don't build in those questions, then you have no ability to answer them. And so in that sense, they're going to be focused in on one specific fact. And if that fact doesn't fully satisfy your answer, you're probably going to have a frustrated customer. The focus that you want to have here is architecture talent, and make sure that you have the ability to attract enough architects to properly give you an environment for the system. Because their key for all of this is that the data demand is not slowing, it's increasing in this case, and our capabilities to keep up with it are not increasing in the way they should. So they're going to be more expensive, they're going to be harder to do, and probably, I hope I don't scare you all with this next set of statistics, but it's important to discuss. Everybody wants to do good, efficient data analysis. So we'll all agree that some data preparation is simply inevitable. Question is how much? Now, if I start you out at 50%, that means you would get sort of a 50-50 approach in terms of every dollar that you invested in there, you get 50 cents worth of analysis and 50 cents worth of data preparation time. And of course, what we'd like to do is make data preparation time as inexpensive as possible. So everybody goes, well, how about if we could get to that? The problem is, anybody that's been in the profession, as many of you on this webinar know, is that the answer is here, that you spend 80% of your time doing data preparation. And this is, everybody knows this except for management who's paying for it. And that's a challenge for all organizations. Here's a couple of specific challenges on the airlines. Think about the warehouse that American and United Airlines have with their frequent flyer data. Now, just to give you an idea of how big and how lucrative these are, in 2020, at the height of the pandemic, American Airlines was $6 billion in market capitalization, not a terrific performance, and their American Airlines Advantage data was valued between $20 and $30 billion, so considerably more than the airline in itself. Similar numbers there at United. This is all due to the fact that organizations have been performing very poorly in their data analysis areas, and even these big guys who should be good at it are experiencing significant challenges around that. The solution to this, now just to simply give you some whiplash, is to start looking at not empowering data scientists to a greater extent. They do a great job. They're doing fine work in terms of what they're doing, but to look at another avenue in the war, another front, if you will. And that front is, of course, knowledge workers. Why knowledge workers? Well, too many organizations simply drop better data in front of other workers. And they say, that's great, but it's a problem. So when we look at this in terms of a problem, what that means is, there's numbers, by the way, are from the Data Literacy Project, which has done a great job of doing work in the area of data literacy as well. So I want to give a shout out to them. But here's a number from their previous survey, which is 48% don't look at the data and they just make a gut decision. Now that's disheartening. We take a lot of trouble. We give them data, we give them dashboards, we do whatever we can to give them good quality data, and they still defer to their gut. Well, that's not the worst of it. The C-suite executives are worse still. 2/3 of them will defer to their gut. And when you're faced with a workforce that has the ability to do something, it will 36% of the time find another way to do it. And I don't know what you do if you're not doing it in a data focused way, but that's probably my own myopia talking, not everybody else. And we're still 14% of them going to task entirely. This is happening in a very significant way for our organization, and we need to do some things to address them. The key is, first of all, recognize that data, whether it's in a warehouse or whatever, is always approached by people in the data area where they think they're coming to the entire space and just realizing they don't have just the tail of the elephant in this case. They only have one aspect of what they're looking at in data, and that it's important for everybody to get back on one place through a data literacy exercise that's built off of Maslow's hierarchy of needs. You don't remember back in high school, real quick, take a big breath, right? It starts off with, if you don't have food, clothing, and shelter needs that are met, then you can never be safe. If you can't be safe, you will not be part of something that is bigger than yourself. If you're never part of something that's bigger than yourself, you won't know your boundary where you end in the self, and everybody else takes over in there, and therefore you'll never get to what we call self-actualization. The TED people came along and stole the term, and now it's called flow. Okay, I don't care what it is. But these 5 levels are kind of important. We can do the same thing in looking at data literacy by saying, we need to educate mobile data spreaders, but they're beyond our control. Similarly, we'd like to educate adult data spreaders. They are also below our control. But as soon as you've crossed this blue line into the knowledge worker category, of which there are 1 billion, we now have the ability through codes of conduct and through employment agreements to specify specific behaviors around data. There are a couple of other levels. We're not going to get to all of them, but the data profession, just know that everybody should be part of all of that knowledge, and that everybody needs to go back through it, particularly data scientists and cyber professionals. You'd be amazed at the number of data scientists that don't understand there are programmatic ways of going about and helping knowledge workers become more manageable with data. I'll give you just a preview into here. This is still focused on helping the organization drive on through. First of all, this particular data scientist, not the one that's pictured, that's just a stock photograph that's there, but is in the elevator and they're talking, and the boss gets on at one floor, looks down at the data scientist and says, "Hey, how's it going down there?" And the data scientist looks up and says, yes, I've actually gotten to a 72%. And instead of getting a "wow, that's great," kind of accolade, instead steam comes out of the eyes and ears and nose, and looking down says, "This organization, we never do anything less than 110%. Don't tell me anything less than 100% in the future. Are we clear in our understanding?" Clearly, that was just a complete miscommunication and an unfortunate understanding. More unfortunate, though, upon further examination of the specific incident, it turned out that a 68% achieve would have been profitable 2 years ago. That's really the ending to this, is to say that there's absolutely no way that most of the data scientists understand the business context in which their solution needs to be delivered. We need to do a lot more work around that. Similarly, we need to have knowledge workers understand that they are becoming stewards of somebody else's data, and that there are specific fiduciary responsibilities, that they're responsible for making sure that the process demonstrates value, and that the process and the data both stay current, because there are specific, as I said, fiduciary responsibilities, and that we are all literally swimming in the same swimming pool around that. So what we have to do is that, while it's great to have things in a data warehouse and where data things happen, yay, we're good at celebrating that sort of thing, we need to also become good at turning those things into things that the people in the corner office care about. Whether it's dollars or whatever it happens to be, we need to make sure that we can move in a direction that helps us do that. And the reason and the way in which we do that is by strategy. And strategy is critical to the development of warehousing approaches. The idea of strategy originally was that it was not a business term, but the business consultants kind of hijacked it in about the 1950s, and it became a thing, a plan that you looked up, went to when things went wrong. Step A, step 27/13, blah, blah, blah. Well, it turns out that's not very operational, and that the better use was what was used before the business consultants picked it up, calling it a pattern in a stream of decisions, which says that strategy is much closer to a process than it is a product. I'll give you just 3 quick examples here. Walmart's former business strategy, you guys all know, everyday low price. Pretty straightforward, and it was learned from the top of the organization to the bottom, to the entire customer base, to every supplier that works with it, a very successful implementation of a strategy. Wayne Gretzky's strategy, he states to where he thinks the puck will be. Great Wikipedia article. If you're looking for more details on it, Wayne did a wonderful job of putting that together. Strategy number 3, if we're in an adversarial situation and we're facing the good guys and the bad guys, we use one strategy if we are both on the floor. Right, we use another strategy if the bad guys are up at the top, and we use still a third strategy if the bad guys are up at the top and we're on the bottom here. So you see why it's important to think of strategy as a process that surrounds what do I do, given that I've seen a pattern in a stream of decisions. And think about it from this perspective: strategy guides workplace activities. So if we go straight to a data strategy then, and say if the workplace can be as big as as understanding the metadata around it, the data strategy then consists of the high-level data guidance that focus on specific business goal achievement when faced with a stream of decisions or uncertainties about data. And that we have to make people understand that data decisions are what most managers are making without understanding that they are making those data decisions, including in the area of warehousing, cloud operations, et cetera, et cetera. Data strategy then articulates how the data moves that you're going to make support the organizational strategy, which is probably a measure of proactive and reactive types of measures. Let's move now into sort of a data practices area. And the idea here is that we really need to reform the question. Most people start out when they're approaching data warehousing saying, how do we build this data warehouse? That seems like a good one, or what should go into this? I've already built it, right? Now, the real question is, I need to specifically articulate a business challenge, and I need the warehousing capabilities that can solve this business challenge. And look at it from that perspective, it means you can address a class of business challenges, but contain types of things like foundational practices, specific project deliverables that should be attempted when the organization has reached sufficient maturity, and understanding that even if you do not correctly get it right the first time, that you have the option of constantly evolving it. So don't turn it on and expect it to be successful, but instead say, here's the first version. We're going to improve these particular areas. Again, could be that speed is one of the important pieces. So that's the data warehousing component of it. I want to turn to the term analytics here and just sort of rag on it for a minute. Here's analytics explained in a graphic in 3 areas: connect any data source, explore and visualize, and share the story. Sounds great. There it is in 4, here it is in 5, there it is in 6, there it is in 7, and there it is in 8. That's Peter's famous 3, 4, 5, 6, 7, 8 method. If I can pull those graphics out of Google Images within a few minutes, the area is not precisely defined enough to have us even talk about it. Let's just look at the typical textbook. This was offered to me to teach by one of the publishing houses here. Business analytics. Well, what is that? It's just analytics. So let's get rid of the unnecessary word. Highfalutin word, information technology. Let's drop that one out of there and say hardware software, which is what we're really talking about. Statistical analysis and quantitative methods. They're the same thing. Let's just use the word once. Mathematical and computer-based models, same comment, but they're just models to help managers gain insight, blah, 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 to make better decisions. That's really what we're talking about here. And then a longer context of transforming data through insight. To shorten it, the process of transforming data into actions through analysis to solve problems, and then supported by tools. So what started out as 2/3 longer than this, close to 90 words, has been reduced by about 31, and it's the same process. What we're really talking about here is the understanding that this is overly described and that we need to just focus on the basics. And particularly notice even that with this definition here, the business context is missing. Whether we're teaching MBAs or we're teaching data scientists, the business context has been missing. And what we really need to stop saying is analytics, because it doesn't mean anything, and stay instead data analysis. understanding architectures, because all systems have minimally these types of architectures in them, and that your data scientists and data warehouses will have to complement these structures instead of compete with them. But this can only happen when they are understood, documented in order to do this. Again, the understanding is the idea that there's a digital blueprint illustrating the commonalities and intersection among these architectural components that forms the basis for your digitization efforts, around which your warehousing efforts are supporting. And that this same information is shareable among the systems and the business subject matter experts, as well as the technology people that are involved in this. And I told you there was a nice answer to this. It turns out that both Mr. Inman and Mr. Kimball got together and said, this is the starting place where we should start, which is called a data vault. And the reason is such that the data vault encapsulates business rules along with the data, so that different sections can happen. Again, a very simple example might be that you might have a Spanish subsidiary that had data recorded up until a certain date in pesos and then incorporated in euros. Now, while that's not a huge thing to overcome, there are those types of issues that are easily handled by this. And most importantly, evolution into either one of the two other data systems that I showed you before is trivial from the starting point. So the data vault, again, it's got historical long-term storage with the business rules that retains all of the lineage information, and consequently has a different series of structures than most, which is hubs, links, and satellites. Again, a little bit more structure up front, a little bit more planning, but very, very good results on this. The pros associated with this are that it's very simple and it provides much faster research to this. The cons are that it's a little bit more complicated and there's not quite as much adoption around these types of topics yet. So this is just a comparison of the Inman, the Kimball, and the other one. But the advice from both of these two gentlemen is to start with the data vault and then evolve into one of those two areas in that. When you're looking at particularly initial warehousing efforts, there are some great starting references that are out there. And I won't say too much more, but many of them you can buy the books, the models are right there, able to be used. For example, if you're doing any kind of ETL, this model, I've given you the URL so you can go download it directly. It will handle virtually any kind of ETL metadata transfer. So this becomes the central point, things going into and out of. There are similarly organizations such as OMG that have provided all sorts of meta models around these types of topics. Now, what we have to work on, as I mentioned before, was this knowledge work of productivity around warehousing. We need to make sure that we, instead of having a $30 million a year warehouse that has exactly one user, it's a very easy cost to calculate, and it's probably clearly understood that that one individual is not adding $30 million to this. But instead, we look at the sort of dying by a lot of unnecessary small cuts. We remove one click from a repetitive process, add them all up, and then start to account for it. That's how I can say that I have saved organizations more than $1.5 billion over the last 40 years in doing this type of work. I've basically followed a wonderful set of theory of constraints, which just holds that in any system, there is going to be something that is blocking that, kind of like clogging the veins. That makes the entire system no stronger than the weakest link in the chain, and that we need to adopt a find, fix, and move on to the next one report. And if that sounds simplistic, it is beautifully simplistic from W. Edwards Deming. So he uses plan, do, check, act, or there's another one he had originally, plan, act, plan, modify, deploy, but everybody goes to PCDA. It just seems to roll off the tongue easier. Everybody understands that's what we're talking about. Speaking of understanding the component, I'm going to tell you two quick data stories, and there's a lot of guidance on how to do this, but let me show you the reasons for these two particular stories around data. First one is that we were involved with the military suicide prevention epidemic. It's been going on since 2010. It's a horrible situation, and to have more of our own warfighters hurt by their own hands than by the enemy's hands. At the time, we just happened to be close by and were thrown in the middle of this thing, and we started mapping data sources and trying to figure out what was going on. And very quickly, we discovered we were operating off of a 30 by 30 matrix with a room that we called our Council of Kernels. So all of these kernels would be sitting around, and Colonel X would get up and say, my row is row 7, please put a U in column 9 and R in column 14, right? And you see how that was very unwieldy. And again, well-intentioned because everybody wanted to do exactly the right thing given all this. So we had a chip we could pull with the Secretary of the Army's office, who came in, slammed the leather-bound asset on the table and said, we are doing things this way. Has anybody got any questions? And really did make a difference, because while everybody was correctly saying my purview of authority extends this far, he said, I'm going to say that all this data belongs to me. And if anybody wants to make an appointment with me and find out why I can't use my data to save my soldiers' lives, they can absolutely come and talk to me. And this transformed, of course, the entire operation and let things know. Most importantly, though, the individual told me that I could use that story with attribution. And I have told that story to more than 100 corporate CEOs, and not a single one of them will take that same step. They permit organizations to fight over ownership of data and continue to have problems around that area. This data set that we put together was clearly an integration data set. We had no idea what the answer is going to be. We have done work on the problem. We understand some more about it, but we are absolutely not done in that particular area. Second example, quickly, just before we finish up here, is the Jan 6 components, which most people are familiar with. And the idea was that the parlor users who were attacking the Capitol with a very leaky social media system on here, great stories to read on the side. Were they really at the Capitol? Well, this certain plot seems to indicate that it was. And this one is a multimedia version of the same kind of thing, of where were people and what was going on at the time. And then ProPublica took together and put a timeline that has all of this type of data. So you can scroll along the lines and see at exactly 3:25 p.m. what was happening in near the Capitol, around DC, or inside the Capitol. And the coup de grace that was just wonderful from an explanatory perspective is these are the cell phone hits that are down near the rally, and you could see the cell phones go to the Capitol. So there's no question that all of that data, even though it's perhaps illegally obtained, was still very conclusive that people from the rally did attend that particular piece. And there's a tremendous amount of positive data that has come out of that. Again, they didn't know what they were going to need. And interestingly, what they did find in the process was a lot of cooperation from the technology community, the techno sleuths that have been helping so far. Almost 1,000 people get charged in this area. Well, we've spent the last 50 minutes looking at warehousing, understanding that the DIMBOK does have a role to play in here and offers some good guidance, but that the general thing that we're looking at is legacy to digital conversion. And that there are two types of data warehousing focuses. One is emphasizing an engineering approach, which we don't want to be bleeding edge, but requires an adaptive edge and trying to further and better engineer what we're trying to put together. The second is a preparation oriented, which is the last mile. Sometimes the two of them can work in conjunction, of course. And that best practices evolve around having an understanding of what you say, that you adopt some sort of repetitive plan, do, check, act type of cycle, and that you call your data on a regular basis with respect to repeatedly looking at strategic direction as that evolves over time, and removing, simplifying, consciously taking data that you're not utilizing a lot out of the environment and making it generally much simpler. So we're going to get to a couple of quick takeaways on this, and then we'll get ready for your questions and invite Zach back to join us at the top. And I see this a lot where we hear 16 reasons for data warehousing failure. I just don't like that. What does poor availability mean? Yes, I understand that could be a problem. I look at the entire process in a very different fashion. So this is the famous use case up here in the right-hand corner. It's an icon, of course. Please don't try and hurt your eyes reading that. But what we're trying to do is say, what's happening here? So here's an example from Wikipedia that says a user is editing a particular article. Now, use cases are kind of useless unless they have a wholly integrated glossary, because we can't capture non-functional requirements without that integrated glossary. We don't know whether an apple is really an apple or an apple is instead a piece of a leaf that has fallen from there. So the planning for them, these non-functional requirements, are detailed as the system's architecture. And that architecture of the warehouse, because most people don't start with that, requires the average warehouse to be built and rebuilt 7 different times before it becomes useful. Now, I've put together a bunch of additional references for you here. I just want to make sure you understand we've got some other events coming up, including we'll be all gathering in DC in the first week in December for DGIQ. Looking forward to everybody seeing that. And I may not have my date on the 13th right, but anyway, other upcoming webinars with that, books for sale, blah, blah, blah. I did document quite a bit the corporate information factory in here, so I'm not going to walk this through here, but just know that there's a lot. Similarly, the DIMBOK gives you a bunch of specific starting out guidance, but just consider these as preliminary starting points. And then there's a good deal of reference material around all of this. Some of it may be contributed by yourselves in here, and I certainly look forward to expanding the collection, making it more useful to everybody as we go forward. So gosh, Shannon, I'm finishing 30 seconds early here today. I must have run way too over or had that extra cup of caffeine before we jumped on, but it was certainly good to be with everybody this afternoon, and we'll go see if you got any questions for us.
30 seconds early, Peter, you're losing your touch. You're always spot on. If you have questions for Peter or for Zach, feel free to submit them in the Q&A, and just to answer the most commonly asked questions, just a reminder, I will send a follow-up email for this webinar by end of day Thursday with links to the slides and links to the recording. Everyone's really quiet out there today. It's I don't know if
we did notice it was a beautiful day at both locations, didn't we?
Too, yeah. Everyone's
Shannon's
outside.
in Portland, I'm in Richmond.
There is a question that came in, Zach, during your presentation. We're a vendor neutral company, so we don't ask for product comparisons from one company to another. But how does Anomalo compare, or what makes Anomalo stand out, and where do you, can you expand on like where you sit in the stack?
Yeah, I think I could do this without, I guess, specifically comparing us to Monte Carlo. So I guess I would separate the realm of having confidence in our data to two different categories. One is data observability. And data observability is like shallow level monitoring, but it covers a lot of our bases. So we might only care about, hey, is my data arriving on time, and is it there in my table? And I want to check that for tens of thousands of tables, but I don't really care much more about the data other than basic metadata checks. Was a column dropped? Did a type change? Things like that. So that's one route. And there are a lot of tools that specialize in that. And then at the other end of the spectrum, there's data quality. And data quality is much more focused on going a lot deeper, caring about the content of the data. So we know that the data is there already. That's pretty basic to get that information. But do we know if that data is correct? Because the only thing worse than making a decision based on no data is making a decision based on wrong data. And if we make a business decision on that, that could have really bad adverse reactions to our business, and stakeholders could be at risk in some type of exposure. So
it makes us look bad, right, Zach?
Yeah, I've definitely been in that situation before when I worked at Capital One. So,
by the way, were you in Richmond at that point?
I was not. I was in Tyson's Corner in DC.
Oh yeah, I grew up in that area. Anyway, we won't bother everybody with details, but yeah, no, absolutely. And what you just said was very important. Capital One is going to have a completely different focus on data quality because of their regulated business, but also they have very clearly articulated that information is the strategy that they were using to grow during those years. And so if the data wasn't right, they were simply growing incorrectly. And they would talk about it internally as well. And it's like saying cancer cells are good. Let's grow more of them because they grow really fast and they're really strong.
Exactly. So I mean, that's a great point. And with data observability and knowing if my data is there, if it's arriving on time, is important. But ultimately, it will be caught one way or another. It might be caught delayed without data observability. Someone will very quickly know as soon as they query the data, oh, it's not there. Oh, it's not fresh. Ideally we would catch it earlier, and that's where data observability is important. And Anomalo already has those features to catch if it's fresh and complete. But where we might not catch issues is the actual data quality. And so there needs to be active monitoring and in a way that's scalable. So unsupervised machine learning, we could use that to catch a wide net and find anything that could be significant, 1 to 5% change in the data that might be different in yesterday's load versus other loads of the data. Where instead of writing a bunch of rules, whether they're done in a no-code way or with a bunch of custom Python, that will get very difficult to manage. And as an enterprise scales, there will be a lot of issues that come with that. So it's a bit of a different paradigm with Anomaly, thinking about it in a very different way. But on top of that, of course, there's always going to be a time and place for custom checks. And so the approach we take with that is it should be as easy as possible. Someone shouldn't have to be a very technical person in order to monitor data that is important to them.
And Zach, if I could just expand on that for a quick second, because I find this is really helpful for most organizations. The idea of the proactive monitoring, which is so important to what's going on. We're not talking here about the notification buttons on your phones that are constantly going off 200 times a day, but that you can fine tune this to the point where you know things that you should know, and that routine things don't constantly just go beep, 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 and distract you in that sort of a fashion. What sort of a percentage do you find that organizations decide to hone in on from that implementation perspective of the proactive monitoring?
Yeah, Peter, I actually really appreciate that question. That's really important. So that can be broken out into, I guess, two different parts. One is what data do we care about monitoring? So what I generally see is when we're onboarding a customer, they start with maybe one or two teams. They could be data engineers, or they could be data scientists or end users who care about a subset of data. This could be anything from 10 to 300 tables to start out. The things that are really important, the ones that impact end users, in which our analytics could be wrong and we can make the wrong business decision. That's where organizations tend to start. And then from there, they expand over time, almost to the entire enterprise data warehouse. So for example, Discover Financial, the credit card company, they are one of our clients, and they, I think, are at 7,000 tables now. Whereas Block / Square, the payment processing company, they've gone
out of Detroit.
Sorry,
out of Detroit, right?
Yeah, I think so. So they've moved from a couple hundred tables to, I think they're at 12,000 right now, and they have 200 users using Anomaly. So it is an overtime endeavor, but we start with the ones that are most important, and then bring in other organizations, other teams who care about other tables, as we continue to have success with that monitoring. Now, on the flip side of that, there's also another very important point. I don't want to be getting false positive alerts. I do not want to be getting too many notifications that makes it difficult to find the ones that are important. So for example, I don't use Facebook anymore because all the notifications I got were not things I wanted to see. So it's the same thing as an end user. If I get too many notifications, it's the same thing as getting no notifications, because I'm going
just
to
noise.
Exactly. So false positive suppression is extremely important, and Anomaly takes that very seriously. And there's a lot of different ways in which it implements false positive suppression. And this is a big reason why, instead of maybe in my legacy system, I might have hundreds of thousands of rules. And let's say a flashy new tool like Anomaly comes my way, and I might be interested in deploying Anomaly in a way where I'll import every single one of my rules over to Anomaly. And then in addition to that, great, I got this unsupervised machine learning to maybe catch the unknown unknowns, the issues I don't know I should be looking for. Phenomenal. But it's still going to create the same issues that I have under my legacy system, where I have way too many checks that could be creating a lot of false positive alerts. Now, Anomaly will take care of a lot of those with its intelligent time series models and machine learning. But a different way to think about it, and this is a new way of thinking about data quality monitoring, is to start with a foundation of unsupervised machine learning, so that I'm not getting alerts for things that really aren't that significant. And then on top of that, only creating checks for the things that are very critical to the business on top of that.
A phased approaches really makes sense for all of these things. I think the important thing for organizations to understand is that you're starting a program here. And that's where most people, I think, they say, well, I don't really need to have quality in here. I'm just going to build the data and move it from my systems. If it's wrong in my systems, I wouldn't be making money, right? Oh, no, it's a very different set of processes. In fact, the average organization keeps its customer data stored across 13 separate systems, which means that integration is always a challenge around this. And the need for automation to this is crazy, because you can't just depend on a Peter or a Zach to actually be there for you for all the time. We might hit that $2 billion lottery, right?
Exactly.
Hey, Shannon, did we stall long enough to get a question or two?
We've got lots of questions coming in now.
Well, then tell us to
It
shut
was-
up.
Yeah, if you figure out the secret to winning that lottery, please let me know.
Absolutely.
So given a limited number of people in an enterprise data warehouse team in a complex organization with many data sources, both internal and external, what is the best way to deal with data integration? For example, when should data warehousing be used in preference to data virtualization or graph databases or vice versa?
Well, of course, the thing to think of it is none of these things are necessarily and or type situations on this. So when you're looking at the value proposition, which is what we're really talking about here, you're saying that in some format, the organization is going to benefit from a model that looks, and again, I'll just flip back into a slide here. And Zach, if you want to pop anything up, just go right ahead to do that. But the organization may look too much like this slide where we started out, where it's difficult to get things around. All the data is of different formats. We're not really sure how to navigate it. It's more mysterious, certainly not very user-friendly and accessible. They got to do something called Pythoning, whatever that is, to go and get access to the data, or worse still, maybe a batch job. That it's problematic. So somebody has to say that taking the step, and this does require not just the action of building this new set of system capabilities that you have, but that you're putting in a new part of the organization, and that this part of the organization is going to be around as a part of your organization in a permanent form, in the same way as your HR program and your finance program are going to be around for as long as the organization assists. Now, if you have trouble with that calculation, it's a very reasonable place to be concerned. What we find is that between 20 and 40% of all IT costs are spent doing some sort of data conversion, improvement, evolution around these. And that taking this to get to a nice architect that I showed in 3 silly PowerPoint slides is really a matter of years in many organizations in order to do this. But on the other hand, if you get a CIO that comes in and says, oh no, we are moving to the modern world, it can literally be accomplished in a matter of months. And it's a wonderful transformation, very jarring transformation. Notice, however, everything that I've said here has nothing to do with filling this full of anything good. So Zach, a pretty good lead to turn it over to you for comment.
I guess nothing on this. Is this question in context of self-service as well?
That is a good question. Don't know.
What if it was?
Yeah.
Okay, go ahead and answer.
Yeah, well, right. I mean, I guess we with all these ETL pipelines and whatnot, the end goal is to make sure that data is accessible. We need to be able to analyze and make decisions on it. So I guess at the end, from the end user's perspective, they're going to be either doing data science or analytics. And for example, in the BI space, we've seen over the past 10 years a large movement from the central IT structured monitoring dashboards such as Cognos and Crystal reports over to the modern visualization tools like Tableau, Looker, Power BI. And the reason why there's been such a big movement is because of the self-service capability, in which end users don't have to go back to central IT to ask them, hey, can you make a small change to this chart? They can just go in there and do visual analytics on their own. So empowering end users to be able to use the data is what I would say from my perspective as an analyst and data engineer, this is all about. And I guess on the side of data quality, we also want to enable the end users to be able to create their own checks. And we want to democratize data quality in some way so that the experts in the data, the people who actually use it on a day-to-day basis, know what's really important and can add their own check without having any coding experience.
And I would imagine some of the metadata in the platform would also be useful in the sense that you could use that for sort of meta information, tracking usage, areas of focus.
Yeah, I mean, as long as that is actual data that can be monitored, then yeah, why not? With data quality is mostly concerned with the actual data itself, rather than usage, but the same thing applies.
Mhm.
And what if not
All right.
necessarily self-service?
Sorry, what was it?
If it's not self-service.
Yeah. Or Peter, if you want to add to that too.
Sure. So you have a challenge around that, as Zach said. The reason self-service is appealing is because people can make their own changes, and they are most capable of understanding best their requirements because they're closest to the business problem that they're trying to solve. And this is a goal of data all along, is to make sure that the right data is in the hands of the right users under the right circumstances. Because if we're forced to go back to a centralized model where only IT can change and then propagate systems, and there are perfectly good reasons. For example, in the military, most systems are of that fashion. They don't really want the soldiers on the battlefield to start messing with settings because it will distract them from their primary motivation, which is obviously to get out there and keep themselves safe and to make sure that the world is safe for democracy around law. By the way, happy voting day, everybody. It is that particular day.
So do you think the data vault model should be created after enterprise data model with the main models as the building blocks with metadata? Otherwise, I'm not clear how data vault would comprehend the quote unquote business rules, since everything could many-to-many hub and satellite.
Yeah, good point. So in the context of this, it is exactly what's envisioned, is to take an enterprise model and go directly into the data model components. And if you ever take Dan's training around that area, he'll show you specifically what the power of that is, because you're going from existing known facts. I mentioned before and drew a line around earlier on. Remember the ETL metadata that you have there. That becomes a tremendous source of input because you've already made it run. The ETL job runs every night or periodically or whatever it is that your frequency is around this. And just having that agreement between the beginning and the end party of what they're supposedly looking at in the same context means that you've got a tremendous amount of source material to start off on this. You'll also find, unfortunately, that some very well-meaning but perhaps not optimal data practices are inserted in there because they didn't have the opportunity of looking at something like Anomaly, where they can actually have an active monitoring on the outside of this. So I don't show in any of my diagrams where it would fit, but one could say it should be assumed as a best practice into warehouse data components around that. So yeah, sort of a long, windy answer, but I think that'll cover. Zach, you want to add anything onto that?
Nope, nothing for me.
Very good.
Those are all the questions that I have right now. Anything you want to add, Peter? I will give everyone a moment to type anything else additionally.
I really do want to go back and say that warehousing is a wonderful thing, but warehousing by itself generally is not going to solve your problem. That it's a combination of three things that we put on our DEMA wheel. Probably some combination of warehousing, governance, and quality may be a good place to start. But it may also incorporate metadata and reference data at different segments. And depending on what you're doing, obviously you can go to other aspects. It's not to say that we're ignoring data storage, because obviously if you're building a warehouse, you're building data storage. But that these things are really things that should be looked at as capabilities. And where most organizations make the mistake is that they come in with a series of use cases. And while use cases are useful, they neglect to address an entire classification of requirements that are critical for the success of integration or practice-oriented warehouses. And so the idea is that if you're being presented with a group of use cases, that's a wonderful thing, and we're glad somebody's done that particular idea. But if they're not using an integrated, trusted glossary to categorize and to define a concrete constrained vocabulary around the project, there is no hope of this thing working, and you'll end up in the same sort of build it, eventually it'll work, rebuilding 7 times over too long of a period of time, which then the organization comes back and says, how are we invested millions in this, not just in dollars perhaps, but in person hours and things like this. How are we ever going to recoup our investment from this? And so the higher the investment, obviously, the more difficult it is to get back out. So the question is, can you use your existing smarts and appropriate technology to go in and not just build a good data warehouse, but build a good data warehouse that's got some good quality data inside of it as well? Zach, over to you.
I really don't have anything else on my side unless there are questions around data quality.
Yeah, well, I did get another question coming in, not necessarily on data quality, but what are the limitations of using warehousing to source data for production applications versus analytics?
I think that they're not going, there may be different based on the two classes of applications that are there. Zach, maybe you can add your thoughts to this too, but it's just a set of constraints. If we're delivering something that is a production to feed into another part of an organization, which is very much a part of the Inman warehouse type of integration here. And again, I'll just go back to the target slide here, where you can see they're connected with an awful lot of different components around their environment. Just as an example of one way it can be done. Having that without the ability to talk about quality around it, and not look at it, in terms of the existing, what we have that's really, really good solid data in there. It's just unfortunately crippling to organizations, but at the same time, it can become a very difficult muck place, quicksand, if you will, where you've put in so much into it that you feel like you have to get something out of it, but all of a sudden you realize you have 30 million a year in bills and one user, and it's clearly not a good ratio in that set of situations.
Perfect. Well, that does bring us to the end of the questions. Again, everyone's very quiet today. It's a good topic, though, like we were talking about, Peter, so essential to the whole discussion on data management and such an important piece of that demo wheel. But thank you, everybody, for all the engagement. Thanks to Anomaly for sponsoring today and help making these webinars happen. Zach, been a pleasure to have you join us today. And thanks, everybody. I'll give you a little bit of time back. Thanks, everyone. Thanks, Peter. Thanks, Zach.
Thank you. Thank you, Shannon.
Thanks all.
Everybody have a great day.